Now, if you go to any cycle shop, modern cycle shop, those little bit bigger, they will have one compressor will be there. Okay, you go to cycle or bike shop, there will be compressor. Then one long pipe will be there. Then you'll be putting in your tube, and so you don't have to pump manually. Okay, so there will be some arrangement will be there. So there actually reciprocating compressor will be there. Okay, so reciprocating compressor will be there. So that reciprocating compressor in one stage normally they will not be compressing whole air, rather they will be making multiple stages. Okay, so there will be two cylinders, cylinder 1, then air take, cylinder 1 you compress, you cool it, again you put in cylinder 2, then you deliver. Okay, so this there will be intercooler. So if we have intercooler in between two piston cylinder arrangement, then my system performance will be increasing. It will take less amount of electricity. Okay, and this intercooler will have lots of fins, so it will be releasing lots of heat. So because ideal process is isothermal process, as we are not so fast so that we can create ideal process. So scientists thought, let's create something which will be mimicking little bit ideal. Okay, so just they put intercooler system to release heat. So first compress it will, when you are compressing, because of Charles law, you can see PV equals RT, temperature will be going up. When temperature gone up, reduce the temperature using intercooler. It is actually condenser, heat will be going outside. Okay, heat will be going outside, then temperature going down, then volume also will be going down, pressure you are maintaining. Then you put into second cylinder, again you compress, maybe you can put another intercooler, again another cylinder. So in that way you are increasing the performance of the whole system. So what happens if I draw the whole thing in PV diagram? It will be looking like this, PV, uh, PV. So if I have only one cylinder, so my compression will be looking like this. Okay, 1, 2, 3, 4. Now you are an engineer, so you thought, let's put two compression system with intercooler. Then what will happen? First you compress up to this level. Okay, 1 dash, then you cool it. When you are cooling, your pressure same, volume gone down. Okay, now again you compress. So this much of energy saving will be there because of your cooling arrangement. Okay, uh, 1 dash, 1 double dash. Okay, so this 1 dash and 1 double dash, in between that area you are saving energy. Okay, so this is area, so this is area represents energy saving. Okay, uh, first stage, this is second stage. Okay, so ideal cycle will be like this. PV, let's say compression is polytropic, isentropic, polytropic. This is isothermal, PV equals constant. This is adiabatic, PV per gamma equals constant. This is polytropic. Okay, so polytropic, PV per N equals C. So gamma normally 1.4, N value maybe 1.33 or something. Okay, because this is polytropic process, N value will be changing. This is V, this is P. Okay, so our target will be to reach towards isothermal. So two stage reciprocating air compressor with intercooler, two stage reciprocating with intercooler. Formula will be like this, P2 equals P1 P3. Okay, so P1 is first one, P1 compressor 1, compressor 1, then P1 I will not write here, I will write here P1, then P2. Now you have intercooler. So P2 after compressor 1 pressure, and we have intercooler, then compressor 2 and pressure is P3. Okay, then intercooler pressure will be P2 equals square root of P1 into P3. Cylinder throughput formula. So QA equals EVPD. So QA equals cubic feet per minute, EV equals volumetric efficiency, PD equals cubic feet per minute. Cubic feet per minute. So in a reciprocating, now you see the problem. In a reciprocating compressor, the swept volume is 0.9 times of the maximum volume. The clearance ratio is. So first you draw the figure. Okay, reciprocating compressor, you are saying that means it will be like this. Piston will be here, piston rod will be here, and valve no need to draw. PV. Okay, now I have clearance volume actually. Okay, now initially you have at point 1, then you are reaching to point 2, then you are reaching to 3, then 3 to expansion will be happening, then suction will be happening, so 3 to 4. Okay, now in a reciprocating compressor, Vs swept volume, so from here to here Vs, so Vs equals 0.9 V1. V1 means initial volume. Okay, maximum volume is V1. V1 is the maximum volume. Okay, and now Vc, this is Vc, this Vc clearance volume or clearance, this is swept volume, swept volume. Okay, so Vc by Vs equals, we have to find, so V1 equals Vs plus Vc, so Vs equals 0.9 Vc plus Vs, so Vc equals Vs minus 0.9 Vs by 0.9 equals 0.1 by 0.9 Vs. So therefore Vc by Vs equals 1 by 9 equals 0.11.